So one of the questions I get asked all the time is, well, you guys, you talk about deduplication as one of the technologies in your box. Well, we already have storage deduplication in our network. What is the difference? So let's dig into that. So storage deduplication, or at least deduplication applied to storage, has been around for a long time. Data Domain, Avamar, both of them have been acquired by EMC over time. They came out with some really cool technologies around storage deduplication. Pretty much every vendor in the space, in the storage space, has some deduplication story today. It's a great technology. It's been proven. It's been around for a while. The primary goal for that technology, storage deduplication, is to reduce the amount of storage required for either primary or secondary storage. The idea is essentially, again, how do I reduce the amount of disk I use for primary or secondary storage? That's really the goal. But on the other hand, if you look at what we do, which is really inter-data center acceleration, the goal that we have is to reduce the footprint of traffic on the wide area network. So traffic that's flowing from point A to point B, data center B, how do we reduce the amount of traffic on that wire? So it's very complementary to what you are doing with your storage deduplication today. So with storage deduplication, you are reducing the footprint of storage, right? The less number of disks, right? You use less disk. With us, you are using less of your WAN so that you can use it for something else. Very complementary, very different. Both are actually important. So if you look at, say replication traffic for as a first example, replication tends to be, either real-time or near real-time. When you're doing real-time or near real-time replication, there is no time in the array or what have you, the storage device, to carry out deduplication. So all the traffic going from data center A to data center B actually does not get deduplicated on the storage side at all. So when that traffic is flowing through the WAN, it's important to make sure that that traffic's footprint is minimized. We can do that. We work at 10 gig, regardless of the speed at which you are replicating, we can handle it because we have a really, we've built a 10 gigabit device. On the other hand, if it's not, so let's talk about backup. In many cases, folks are doing, batch job backup so that they have deduplication going on in the branch and then they push that traffic on the WAN. In general, that the goal is to carry out reduction of storage footprint, but that traffic is already deduped. Even in that case, even in that kind of one-off case, there's a lot of value that you can find in doing both storage deduplication as well as network deduplication. And the reason for that is really in how deduplication is carried out and at what level. What storage is doing is it's looking at repetitions in blocks. So they have a bunch of blocks on a disk. This block could be 32 kilobytes, 8 kilobytes, or what have you, and they're trying to find blocks that repeat. If there is a large big chunk, let's say 8 kilobytes of data, which is repeating, they will deduplicate it. But what that really means is they will find the repetition and replace the block with an identifier. But that's happening at an 8 kilobyte level. We're working at the byte level. We're on the WAN. So even if there is some level of deduplication going on for your backup traffic, there's a lot of value in doing network deduplication, which is what we do on the wire. And let me kind of illustrate that. Let me kind of talk about what I mean by that. So imagine, if you will, this is a disk. There are a bunch of blocks on this disk. What storage deduplication is doing is it's trying to figure out whether block A, block B, C, D, E, F, G, H, I, J. If block A is the same as any other block in this system. Let's assume that is the case. Let's say we find out that A is the same as say G and I. Okay? So what I just did was, assuming each of these blocks is say 8 kilobytes, I just reduced 8 times 2, so 16 kilobytes of space on this disk. It's great, it's awesome, it's a very good solution. Okay? But what will end up happening over time is that some of these blocks that were the same at some time, they will keep changing. That's the nature of data, right? So let's say I change 1 byte in I. As far as storage deduplication is concerned, it's a brand new block. So at that point, you no longer have all of these matching each other. You just have A matching G, but I is a different block. Okay? But if you take this block and send it through our system. So first I sent, let's say, so packet 1, it has a block which is I. So that becomes many packets, and then I send I second block, right? So this small little area is changed. We will find that within that block. So we look at that little space, we'll figure out that this is the same block that we've seen before, rather this is the same data that we've seen before. This is the only thing that is different. Everything that has been seen before will not be sent across the wire. But only the things that are new, the new changes to that block, they'll be sent across the wire. So here's what happened. Your storage replication, deduplication, it reduced your footprint on your storage device. But in addition to that, networked deduplication helped by making sure it identified the changes that are going on your data. If there are any, we will find them, we'll make sure they're reduced. This is an optimal way of deploying backup. Of course, as I mentioned earlier, if it's replication traffic, typically there is no storage deduplication because it's running really fast. In that case, you must have network dedupe so that your WAN footprint at least it's minimized. But with backup, if you do carry out storage deduplication today, that's great. It makes a lot of sense to do network deduplication in addition to your existing storage deduplication.